Hello everyone. We were doing combination. In our last class, we talked about the different formulas for different situations. So when we are finding out combinations, for example, if I have 10 people and out of 10 people, I want to form a committee of 6 people. I want to form a committee of 6 people. That means I only want to choose 6 people out of 10. So how many ways will be there? 10C6. How many ways are there to select 6 people from 10? There will be 10C6. Suppose I give you 5 men and 3 women. I want to form a committee of 2 men and 1 woman. In how many ways can I do that? First, from 5 men, let us select 2 men. So 5C2. From 3 women, select 1 woman. So 3C1. And since it is and, I want both of them. So multiply. Yes.
Yes, ma'am.
Then we talked about different scenarios. First, we talked about number of handshakes. What was the formula for number of handshakes? NC2. Out of 10 people for a handshake, we only want 2 people. So out of 10, just choose 2 people who are going to have a handshake between them. So formula for handshake is NC2. If there are n points, none of which are collinear, none of which are collinear, then number of lines. The formula was again for line we only want 2 points. So from total choose 2 points. If I want to form a triangle, then for a triangle, how many points we need? Three. So from n choose 3 points. But if out of 10 points, 6 are collinear, out of 10 points, 6 are collinear, then number of lines will be total lines, subtract the collinear ones and add 1 because all the collinear will give you 1 line. If I want to form number of triangles, it will be all the lines subtract so all the triangles subtract the collinear ones. Here we don't add 1 to it. I hope you all remember this.
Yes, ma'am.
Then if I have 7 horizontal and 6 vertical lines, then number of rectangles that can be formed was for a rectangle, I want 2 horizontal lines and I want 2 vertical lines. So choose 2 horizontal lines, 7C2. Choose 2 vertical lines, 6C2. I want both of them, so multiply. If you want number of squares, so subtract 1 from both, subtract 1 from both. So 6 into 5, then 5 into 4, then 4 into 3, 3 into 2 plus 2 into 1 till we get 0. Till we get 0. Then we had a formula for number of diagonals. Number of diagonals was all the lines minus the sides. If I have 4 points, if I have a quadrilateral, then 4 vertices and 4 sides. So out of 4 vertices, out of 4 points, I have 4C2, 6 lines. But out of those 6 lines, 4 are the sides itself. So if I subtract those 4 lines, I get 2 diagonals. I get 2 diagonals. Okay, let us begin exercise 7.5, the last exercise of the chapter. Exercise 7.5. We will first discuss the word problems. In combination, we usually don't have a larger question. Exercise 7.5. 6.1. How many selections of 4 books can be made from 8 different books? From 8 books, we only need to select 4 books. How many ways are there? 8C4. Calculate 8C4. 70. Done. Second, in how many ways 9 stamps can be made from 11 different stamps? Out of 11, choose 9. Now 11C9 is same as 11C2. Calculate. 55. 7. A baseball team has 13 members. How many lineups of 9 players are possible? 13C9. Same as 13C4. 715. Second, 12 persons meet in a room. How many handshakes? We just talked about the formula for handshake. What will be the answer? 12C2. So 12 into 11 upon 2, 66 handshakes. Any doubt?
No, ma'am.
Question number 8. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 are compulsory? So from 9, we have to select 5 courses. But out of those, 2 are compulsory. So that means there are remaining only. From 9, we had to select 5. But 2 are compulsory. So only 7 are left. And from that, we only have to select the remaining 3. So basically, from 7 courses, we have to select 3 courses. How many ways will be there? 7C3. 35. Second, in how many ways a committee of 3 girl and 2 boys can be made out of 7 girl and 5 boys? In how many ways can we do that? So 3 girls has to be selected from 7. So 7C3. 2 boys have to be selected from 5. So 5C2. I want both of them. So multiply. So 35. 5C2 is 10. So 350. Any doubt?
Ma'am. No, ma'am.
Bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. How many ways can we do that? 5C2 into 6C3, 10 into 20, 200. Hmm? Second, a book contains 7 different maths books and 5 different physics books. We want to form a group of 3 maths and 3 physics books. I want 3 maths and 3 physics books. 7C3 and so multiply 5C3. So 35 into 10, 350. 10. What is the number of ways of choosing 2 red cards from a pack of 52? In a pack of 52, how many red cards are there? How many red cards are there? 26. Out of those 26 cards, I want to pick up 2 red cards. So out of 26, choose 2 cards. Answer 325. Second, choose 3 picture cards. How many picture cards are there? Picture cards are KQJ. So 3, 3, 3, 12 times. So out of 12, we want to select 3 picture cards. So out of 12, choose 3 cards. 220, 220. Any doubts?
Ma'am.
No, ma'am.
Try the first four sums now. 1, 2, 3, 4. Number 1, 15C11. Same as 15C4. 15 into 14 into 13 into 12 by factorial 4. Answer
365.
1365. Second, 100C98. Same as 100C2. So 100 into 99 by factorial 2. Answer
4952.
4956. Very good. Third, 52C52. 1,
1.
2, 1. 2C0 plus 3C1 plus 4C2. 2C0 is 1, 3C1 is 3, 4C2 is 6, so 10.
Yes, ma'am.
Second, 19C17 plus 19C18. This is same as 19C2 and this is same as 19C1. 19 into 18 by 2 plus this is 19. 171 plus 90. 190. Does it match?
Yes,
Yes,
ma'am.
ma'am.
Question number 3. 35C(n plus 7) equal 35C(4n minus 2). So if two combinations are same, then either n plus 7 is same as 4n minus 2, or if I add them, I'll get 35. So 9 equal 3n. So 3 equal n. 5n equal 30. N will be 6. So there are two possibilities, n equal to 3 or n equal to 6. Any doubt?
No, ma'am.
Question number 4, 1. NC10 is same as NC12. So n will be 10 plus 12, 22. NC3, 22C3. 22 into 21 into 20 by factorial 3. Answer 1540. Yes.
Yes, ma'am.
Yes, ma'am.
Second, 16CR is same as 16CR plus 2. Then R plus R plus 2 will be 16. 2R will be 14. R will be 7. Now, we want to find RC4, that is 7C4. Factorial 7, factorial 4, factorial 3. So 7, 6, 5 by 6. Answer is 35. Yes.
Yes, ma'am.
Question number 5. NPR equals 720 NCR. NPR divided by NCR is 720. NPR divided by NCR we got as factorial R, and 720. In order to express it as a factorial, we divide it by 2, then by 3, then by 4, then by 5. So it is 2, 6 into 5 into 4 into 3 into 2. 1 we can always write. So this is factorial 6. So R will be 6. R will be 6. Yes. Done? Okay, try a sum question. Find n if NC4, NC5, and NC6 are in AP. Right. Since they are in AP, what is AP? Difference same. So difference between second and first is same as third and second. So factorial n. Okay, first we can write in this way. 2 times NC5 equal NC6 plus NC4. So twice factorial n minus 5, factorial 5, factorial n minus 6, factorial 6, factorial n minus 4, factorial 4. From the numerator, I can take factorial n common and cancel out from all the three terms. Now, in the denominator, if you see, n minus 5, n minus 6, n minus 4. The smallest is n minus 6. So we'll transform all of them into n minus 6. So n minus 5 into factorial n minus 6. This is 5 into factorial 4. This is 6 into 5 into factorial 4. N minus 4, n minus 5, n minus 6. Now, n minus 6 is common in all the three. Factorial 4 is common in all the three. We can take common and cancel out. 2 by 5 into n minus 5, 1 upon 30 plus 1 by n minus 4 n minus 5. So 2 by 5 n minus 5. Let's take LCM. 30 n minus 4 n minus 5. N minus 4 n minus 5 plus 30. We can cancel n minus 5. 5 6. So 12 n minus 4 n square minus 5n minus 4n plus 20 plus 30. 12n minus 40n. 0. N square minus 21n plus 98. Midterm 17 and 4. Sorry. So n is either 17 or n is equal to 4. But my fault. I'm so sorry. So 14 sevens. So n equal to 14 or n equal to 7. If I would have got n equal to 4, can I accept n equal to 4 as the answer? Can I accept n equal to 4 as the answer? No. Why not? Because if you look here, I already have NC5, I have NC6. That means I'm already choosing 5 people, I'm choosing 6 people. That means I should have a minimum of 6. Otherwise, how will I choose 6 people if I have only 4? Right? So if you have written NC6, then has to be minimum 6. Clear?
Yes,
So,
ma'am.
Now, there are certain sums, it's not there in your books. There are certain sums that have both combination and permutation together. For example, how many words can be formed out of 10 consonants and 5 vowels using 4 consonants and 3 vowels at a time. Right. How many words can be formed? See, I cannot directly write 10p4 or 5p3 because it's a word, so permutation will be used. That's wrong. Because what I need to do is I need to first bring the consonants from here. I need to bring the vowels from here. Then I have got 7 letters. Those 7 letters will be arranged among themselves to form the word. So my first job is to select in bits and parts. Once you have selected all of them, then you arrange them. So yes, the job is both selection and arrangement, but I cannot use permutation because when we apply permutation, it will be 10p4. That means out of 10, I have selected 4 consonants and I've arranged them also. Out of 5, P3. Out of 5 vowels, I have selected 3 vowels and I have arranged them. But I never said that the consonants should be arranged among themselves and the vowels should be arranged among themselves. They cannot mingle. That is not written here. So what we do is we are going to first make the selections individually. Once you have made all the selections, then arrange all the selected letters. So out of 10 consonant, we will first select 4 consonants. So number of ways how to present of selecting 4 consonants. 10C4. Number of ways of selecting 3 vowels. What will be the answer? How many ways are there to select 3 vowels?
I see 4.
5C3. 3 vowels. So 10C4 is how much? This is 210 and this is 10. So the selected letters. So how many letters did we select? How many letters have we selected? How many letters have we selected?
220.
How many letters have we selected, chosen? 4 consonant and 3 vowel. I've selected 7 letters. Now arrange those 7 letters. 7 factorial ways. That is 5040. So total number of ways. Selection as well as arrangement. So 210 into 10 into 5040. Did you all understand?
Yes, ma'am.
Any doubts? First, you have to
No, ma'am.
select in bits and parts. First, select the consonant from here, then select the vowel from here. So, you have selected the 7 letters. Now, the only thing remaining is to arrange them. So, those 7 letters can now be arranged in how many ways? 7 factorial ways. We cannot apply directly permutation because if you apply permutation, consonant will be arranged among themselves, vowels will be arranged only among themselves. But that is not what I want. I want them to mix together. I want the consonants and vowels to also sit together. So we first select the consonant from here. From this bucket, I select the vowel, and then in the new bucket, I arrange them. Is it understood, guys?
Yes, ma'am.
Yes, ma'am.
Last question. How many 4-letter words can be formed from mathematics. Right. Answer, guys. Oh,
2474.
I can't hear.
2474.
How? See, if I want to form word, that means definitely the possibility of arrangement is there. So if you directly tell me there are 11 letters, select 4, 11C4 and arrange them. If you directly apply 11C4 or you apply 11C4 into factorial 4, it's wrong. Why? Because do you know the 4 letters that you have selected, does they have any repetition? Do you know that? No, we don't, right? So in this case, what will happen is we need to first think about what those 4 letters can be. Because until and unless I know what my letters are, I won't be able to arrange them. So the word mathematics has total 11 letters, right? In those 11, there are 2M, there are 2A, there are 2T, and then 5 single letters, right? Agree? So if I want to select 4 letters, it can so happen that I have 2 pairs. I can have 2M, 2A, 4 letters. I can have 2A, 2T. I can have 2M, 2T. Yes or no? Yes or no?
Yes, ma'am.
So first cases, I can have out of 4, 2 repetitions. So how many pairs are there? There are 3 pairs. Out of 3 pairs, how many do I want? I want 2. So in how many ways can I first select them? Out of 3, I want to choose only 2 pairs. So out of 3, I want to choose 2 pairs. Did you understand?
Yes, ma'am.
So as soon as I selected 2 pairs, for example, I got 2M and 2A. So yes, 4 letters got selected. Now those 4 letters have to be arranged because it's a word. So 4 letters can be arranged in how many ways? 4 factorial. But in that 4 factorial, there are 2M and 2A. So there is a repetition. So I need to divide. Yes or no?
Yes.
Understood.
No, ma'am.
What we want is to form 4 letters, right? Suppose if I tell you those 4 letters are MATH. So all different. How many ways are there to arrange them? Factorial 4. If I tell you the letters are double MAH, 4 letters, so 4 factorial. But to arrange them, there are 2 M's repeating. So I have to divide by factorial 2. It may so happen that I have 2M and 2A. So yes, I have 4 letters. So arranging them is 4 factorial. But there are 2 repetitions. I need to divide. So the selection has to be monitored because if I don't know which letters I have selected while arranging the letters, how will I know whether I need to divide by the repetition or not? Right or no? So I want to monitor what my 4 letters are. So my case one is supposingly I have 2 pairs. So I can either have 2M, 2A, 2A, 2T or 2M, 2T. So there are 3 possibilities or 3C2. Out of 3 pairs, pair of M, pair of A, pair of T. I want to select any 2 pair. So out of 3 pair, choosing 2 pair. So as soon as I selected 2 pair, whether they are 2A, 2T or anyone else, I got 4 letters. Now I can arrange them to form a word. So factorial 4. But since there are repetition, I need to divide it by factorial 2 twice. Is it understood?
Yes, ma'am.
What will be case 2? What will be case 2? Case 2. There's something in between also. I can have 1 pair and 2 single. I can have that also. There's only one repetition. So select a pair. In how many ways can I select a pair? In how many ways can I select a pair? There are 3 pairs. I need to select one, or directly 3 ways. Either M will be selected, 2A will be selected, or 2T will be selected. So there are 3 ways to select a pair. Now coming to single, I want 2 different letters basically, right? So already I have these 5 different letters. Supposingly in the pair, I selected 2M. That means another repetition is not allowed, right? But having 1A and 1T is allowed. I'm not allowed to have 2A's. I'm not allowed to have 2T's. But I'm allowed to have 1A or 1T. So I have a total of 5, 6, 7. I have 7 singles. I have total 7 singles. Suppose in this pair, I selected 2M. Now these remaining 2 letters can be selected from A, H, E, T, I, C, S. Out of these 7 letters, I can select any 2. So the 2 letters, the 2 single letters can be selected in 7C 2 ways. So 1 pair and 2 different. So a total of 4 letters. So 4 letters can now be arranged in factorial 4 ways, but there is a repetition. So divided by factorial. Clear?
Yes, ma'am.
And case 3. All different, all distinct, all single, no repetition. So how many possibilities? And this M can also come, right? I cannot have 2M, I cannot have 2A, I cannot have 2T, but I can have 1. So I have a total of how many letters? 8. Out of 8, how many do I want to select? 4. 8C4. Yes, I have selected the 4 letters. Now arrange the 4 letters. 4 factorial. Is there a repetition? No. Did you all understand?
Yes,
Yes.
ma'am.
Let's calculate. 3C2. 18, I think. Total. I'll add them. Double 202. Is the calculation okay? और क्या होगा? चारों single, एक repetition, 2 repetition. That's it. In this particular word. Any doubts, guys?
No, ma'am.
Ma'am.
All of you understood?
Yes, ma'am.
Yes, ma'am. That's the end of this chapter then.